Hello everyone, welcome to this lecture. Today we are going to discuss about Unit 2, which is Relation and Ordering of Semester 2 of BCA in Gujarat University. To understand what is relation, first of all we need to understand what is Cartesian product. So if two sets are given A and B, where A is equals to 1, 2 and B is equals to ABC, if we relate every element of A to every element of B, then it is called Cartesian product A cross B, which is, if we are mapping from A to B, we are connecting 1 to A, 1 to B, 1 to C, similarly 2A, 2B and 2C, which is also shown in this diagram. 1A, 1B, 1C, 2A, 2B and 2C. So this is called Cartesian product A cross B. Every element of A is mapping to every element of B. Here you need to take care that A cross B is not equal to B cross A. So if we take B cross A, it would be A1, A2, B1, B2, C1, C2. So you can clearly see that A cross B is not equals to B cross A. Now, what is relation? If A and B are two sets with finite elements, then the relation A to B is a subset of Cartesian product. So, a relation is a subset of Cartesian product. And it is a set of ordered pairs of elements of a set A and B like AB, where A belongs to A and B belongs to B, written by A relate B. If I take one example, R1, then it would be 1A, 1B. So, R1 is a one type of relation which is subset of Cartesian product. Now, what is complement of a relation? Here, two sets are given again. A is equals to AB, B is equals to 1, 2, 3. A cross B is A1, A2, A3, B1, B2, B3. If one relation is given, which is R is equals to A1, A2, B1, then the complement of this relation denoted by R bar or R dash is equals to the remaining elements from Cartesian product apart from the relation given, which is A3, B2 and B3. Okay, here we can see R union R dash is equals to Cartesian product, which is A cross B, and intersection of relation and its complement is phi. Okay, there is nothing common between one relation and its complement. The next topic is matrix representation of a relation. Here, let R be a relation from a set A is equals to 1, 2, 3, 4. And relation is defined by all the xy which belongs to R if x is divisible by y where xy belongs to A. Then, how we can write this relation? R is equals to all the xy where x can be divided by y. The elements of R would be 1, 1, 1, 2, 1, 3, 1, 4, 2, 2, 2, 4, 3, 3 and 4, 4. To represent this relation R in the matrix form, we will first write all the elements of a set in row as well as in column. To represent a relation in the matrix form, what we can do is, we will write 1 where the element is present and we will write 0 where the element is absent. Here 1, 1 is present, so in 1, 1, A1, 1 we have written 1, 1, 2 is also present, so A1, 2 will be 1, 1, 3 is also present, so 1, 3 will be 1 again, and 1, 4 is also present, so we have written 1. In the second row, 2, 1 is not present, so we have written 0 over there. 2, 2 is again present, so we have written 1. 2, 3 is not present, so we have written 0. And 2, 4 is present, so we have written 1. In the third row, 3, 1, 3, 2, both are absent. So we have written 0 in place of both of them. 3, 3 is present, so we have written 1. And 3, 4 is again absent, so we have written 0. In the fourth row, 4, 1, 4, 2 and 4, 3 are absent. So we have written 0 over there and only 4, 4 is present. So we have written 1 over 4, 4. The next topic is graph representation of a relation. Here, two sets A is equals to 2, 3, 4 and B is equals to 3, 4, 5 are given. And the relation is defined as x relate to y is x is less than y. So, all the first element, which is x, will be less than the second element. You can clearly see that 2 is less than 3, 4, 5. So, we have written 2, 3, 2, 4, 2, 5. 3 is less than only 4 and 5. So, we have written 3, 4, 3, 5. And 4 is only less than 5. So, we have written 4, 5. So, the relation is defined like this. If we want to represent this relation in a graph form, how we can do? First of all, we will take all the elements and write it as 2, 3, 4 and 5. You can see the first element is 2, 2, 3. 2 is being mapped to 3. So, we will start with 2 and end at 3. First element would be 2, 3. Second is 2, 4. Third is 2, 5. Next one is 3, 2, 4. So, it will go like 3, 2, 4. Next is 3, 2, 5. And the last one would be 4, 2, 5. So, by this way, we can represent one relation in a graph form. Now, we will see the basic properties of relation. The first one is reflexive relation. A relation R on a set A is said to be reflexive if for all A belongs to A, AA belongs to R, then it is called reflexive relation. For example, if a relation is given A is equals to ABC and R1 is equals to AA, AB, BB and CC. Here you can see AA is present in R1, BB is also present in R1 and CC is also present in R1. So, this is called reflexive relation. The second one is irreflexive relation. A relation is said to be irreflexive if for all A belongs to A, AA does not belongs to R. Any AA type of element is not present in relation, then it is called irreflexive relation. For example, R2 is BC and AC. Here you can see any AA type of element is not present in R2. So, this is called irreflexive relation. The next classification is non-reflexive relation. If a relation is neither reflexive nor irreflexive, then it is called a non-reflexive relation. Here, R3 is equals to AA, BC and BB. You can see AA and BB are present. CC is not present, which means some AA type of pair are present and some are absent. Then it is called non-reflexive relation. Again, what is reflexive? All AA type of elements are present, then it is called reflexive relation. All AA type of pair are absent, then it is called irreflexive relation. For example, R2. And some are present and some are absent, then it is called non-reflexive relation. For example, R3, in which CC is absent but AA and BB are present. The next property is symmetric relation. What is symmetric relation? So, a relation R on a set is said to be symmetric if for all AB belongs to A, AB belongs to R, BA also belongs to R. If AB type of element is present in some relation, BA type of relation must be present in that relation. For example, for A is equals to 1, 2, 3, R1 is 1, 1, 1, 2, 2, 1, 2, 3 and 3, 2. You can see 1, 2 belongs to R1, 2, 1 also belongs to R1. So, AB is present in R1, BA is also present in R1. Similarly, 2, 3 belongs to R1, 3, 2 also belongs to R1. So, for all AB belongs to R1, BA also belongs to R1, then it is called a symmetric relation. Diagonal pairs are allowed in symmetric relation. What is asymmetric relation? A relation R on a set A is asymmetric if AB belongs to A, AB belongs to R, BA must not belongs to R. AA type of relation is not allowed. Here, see R2 is equals to 1, 2, 1, 3 and 3, 2. You can clearly see 1, 2 is present in R2, but 2, 1 is not present in R2. Similarly, 1, 3 belongs to R2, but 3, 1 does not belongs to R2. 3, 2 belongs to R2, but 2, 3 does not belongs to R2. So, this is the example of asymmetric relation. R2 is asymmetric relation. You can also see that any AA type of pair is not present, which means 1, 1, 2, 2 or 3, 3 is again not present in R2. That is called asymmetric relation. The next property is antisymmetric relation. A relation R on a set A is said to be antisymmetric if for all AB belongs to R, AB belongs to R, BA also belongs to R, then A is equals to B. If AB belongs to R1 or AB belongs to R, BA must not belongs to R, but AA type of relation can be present. Here, for 1, 2, 2, 1 is not there. For 1, 3, 3, 1 is not there. For 3, 2, 2, 3 is also not there. But 3, 3 is present. So, this is the basic difference between asymmetric relation and antisymmetric relation. In asymmetric relation, AA type of pair is not allowed, but in antisymmetric relation, AA type of pair is allowed. The last property is a transitive relation. A relation R on a set A is said to be transitive if for all ABC belongs to A, AB belongs to R, BC belongs to R, then AC also belongs to R. For example, one relation is defined as R1 is equals to 1, 2, 1, 3, 2, 3 and 1, 1. Here you can see 1 is connecting to 2, 2 is connecting to 3, so 1 connecting to 3 is also present. For 1, 2 belongs to R1, 2, 3 belongs to R1, 1, 3 also belongs to R1, then it is called transitive relation 1, 2, 2, 2, 2, 3. So 1, 2, 3 is also present in this relation. Then it is called transitive relation. So these are all the basic concepts of relation. In the next lecture, we will start with the examples on the base of relations.